So the next thing we're going to look at is two really important applications of prime factorization. In other words, two things that we can use prime factorization to do. And the first is called the greatest common factor. Greatest common factor is simply a fancy way of saying the biggest factor that's in common to both terms. The biggest factor in common to both terms. Remember, a factor is simply a number that can be multiplied to make another number. So we said the factors of 6 are any numbers that multiply to make 6. 1, 2, 3, and 6 are all numbers that multiply to make 6. So the greatest common factor, and we normally use the abbreviation GCF because it gets to be a bit old to write greatest common factor over and over again. So the greatest common factor, the GCF, is simply the biggest number. If you have two numbers, it's the biggest number, the biggest term that is a factor of both of them. So this involves having two different terms and finding what's in common to both. That another way of saying it is the biggest number that divides evenly into both terms. So let's say I gave you the terms 12 and 40. Well, you could think about what are the biggest numbers that divide into 12 and 40 evenly? Or what are the biggest factors of both of those numbers? What's in common to both of them? Well, you could sit and think about it and say, well, let's see. They're both even numbers, so I know that 2 divides evenly into both of them. But the question is 2 the greatest? Is it the biggest factor of 12 and 40? Well, 3 goes into 12, but 3 does not go into 40. What else goes into 12? 4 goes into 12, and 4 also goes into 40. So 4 is bigger than 2. So 4 could possibly be the greatest common factor. Well, what else goes into 12? 6 goes into 12, but 6 does not go into 40. Is there anything else that goes into 12? 12 goes into 12, but 12 does not go into 40. So 12 would have to be the greatest common factor of 12 and 40. So you can see that by just a little thinking and a little trial and error, you can arrive at the answer in most cases. But I'm going to show you a trick to quickly find the greatest common factor in a minute. The other word we're going to look at is the least common multiple. The least common multiple is in some ways the exact opposite. It's the smallest multiple that's in common to both terms. So let me explain what a multiple is. A multiple is simply a number that's produced by multiplying another number. In other words, if I were to ask you the multiples of 6, well, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, out of your way here, 6 times 5 is 30. These are the multiples of 6. These are the products that are produced after multiplying by 6. So the least common multiple is the smallest multiple common to both terms. So if I give you two terms, like let's say the two terms are 12 and 36, if I were to give you those two terms and to say find the smallest multiple of them, you could start writing out the multiples of each one and see what the smallest common multiple is. So 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48. You could write out some of the multiples of 12, and then do the same thing for 36. 36 times 1 is 36, 36 times 2 is 72. Well, hey, wait a minute. We didn't even have to go very far. 36 is in common. So the least common multiple of 12 and 36 is 36. We usually use the abbreviation LCM for the least common multiple. So now that you understand what the greatest common factor is, it's the biggest number that divides evenly into both of the terms, or you could say it's the biggest factor of both terms. And the least common multiple is the smallest number, the smallest term that's a multiple of both terms. Now that we know what both of those are, let's use our prime factorization to find these two terms, to find these two results. And I think you'll find that this is an easier way to do it than to just list all the multiples or list all the factors. So our first example is 24 and 36. Let's find the prime factorization of both of these, and then we'll use that to find the greatest common factor and the least common multiple. So let's first do the prime factorization for 24. Again, 24 breaks down to 6. I'm going to use the algebraic multiplication. 6 times 4, which breaks down to 2 times 3 times 2 times 2. So these are all the prime factors of 24. Now I'll do the same thing for 36. 36 breaks down to 6 times 6, which breaks down to 2 times 3 times 2 times 3. Okay, if I want to find the greatest common factor of 24 and 36, all I need to do is circle whatever is in common to the prime factors of these terms. So I'm going to start all the way at the left. My first term is 2. I'm going to look at the prime factors for 36 and see if there's anything matching over there. And I see that 36 also has a prime factor of 2. So I'm going to circle that 2. So far they have a 2 in common. What else do they have in common? The next term is a 3, and this also has a 3 in common. So if they both have a 3 in common, I'll circle that. Let's see if there's anything else in common. There's a 2 here, and there's a 2 here. So far we have a 2, a 3, and another 2 in common. Here's a 2, here's a 3, there's nothing else in common. So what I can write for the greatest common factor is 2 times 3 times 2. That's the greatest common factor. And what does that equal? 2 times 3 is 6, and 6 times 2 is 12. So I can say that the greatest common factor of 24 and 36 is 12. And if you think about it, 12 is the biggest number that divides evenly into 24 and 36. Okay, so then if I wanted to find the least common multiple, all I have to do is take the terms that are not circled, the terms that are not in common, for either one of these. I can either choose the factors of 24 or the factors of 36. And take the terms that are not circled, that are not in common, and multiply by the opposite term that we started with. So if I choose to start with the 2 here, with the 24's non-common, uncommon factors, I'm going to multiply that 2 by the 36. So 2 times 36 gives me 72. And that is the least common multiple. If I wanted to, I could have started over here with this 3, the term that was not circled from the 36 factors. And I'm going to multiply that 3 over here by the 24. Well, what's 3 times 24? 24 times 3 equals 72. So you get the same answer either way. So again, you work out the prime factorization just like we did in our